This Python library, PromptLibretto, is for building structured dynamic system prompts at runtime using a declarative model called a registry. As soon as you want an LLM's behavior to vary by persona or context and conversation state, hard-coded prompt logic and f-strings stops scaling. You end up with concatenated strings across a code base with inconsistent prompt construction, with no reliable audit trail, and no clear understanding of what the model is actually receiving. PromptLibretto replaces this with a registry-based architecture. The registry is a JSON document that defines every section of a prompt, the relationship between the sections, required versus optional content, random or conditional selections, and runtime assembly behavior. At generation time, the engine assembles the final prompt dynamically from that specification. If you want an LLM's behavior to vary by persona, mood, context, or conversation state, hard-coded prompt strings stop scaling. As soon as you want strict control over dynamic behavioral precedence and clear auditing capabilities, that's when you need to adopt and adapt to manage that complexity. PromptLibretto is an effective abstraction layer, and it is not opinionated about how you structure your prompts internally. It is a simple, organizational framework that has clear mechanics for how to manage a wide range of use cases while keeping the system auditable and maintainable. Typical patterns that emerge without a systematic approach are hard to navigate as a result of concatenated strings across the codebase, inconsistent prompt construction leading to irreproducible results, and there's no clear understanding of what the model is actually even receiving. PromptLibretto is a system designed to orchestrate this kind of complex behavior. Through layered registries, we can apply distinct behavior rules sequentially, enabling real-time adaptation when registry definition or input context changes dynamically. The framework builds the prompt structure before filling it with runtime data. The registry is the authored blueprint. The runtime state is a per-call set of choices you make from that blueprint. This is what lets one registry produce different prompts without editing the registry itself. You write it once, it never changes at call time. Everything that varies lives somewhere else. A section is a named bucket of authored items with a type, required flag, and an array mode. Sections are essentially just slots. The registry is the board they live on. Registry state and section state are per-call runtime choices. The selected items, the slider value, the template variables, it's all the same registry, just different state, different prompt. Item helpers are typed Python objects that live inside sections. I've abstracted these for you based on what's most commonly used with LLMs, and I've just defined them as persona, sentiment, static injections, runtime injections, output directions, prompt endings, and groups. Each type knows what it contributes and how to render itself. But you are not required to utilize these item helpers. PromptLibretto supports designing your own custom abstractions and implementing them yourself. At generation time, the engine walks the assembly order, resolves the current state, fills template variables, and produces the final prompt as a single string. This is the core mechanic, a declared auditable assembly path, instead of scattered string concatenation. The prompt constructor is the studio built on top of PromptLibretto for creating and testing chat model configurations. It includes a builder, which is a no-code template-based interface for registries, configuring memory systems, or writing assembly logic, a studio, which loads those registries and tunes runtime state, an ensemble, which is a tool to explore how your registry design choices influence the behavior of LLM-driven conversation, and finally there's an experimental chat builder. The chat builder is a two-pane interface for building registries through conversation. The left pane is the assistant chat, the right pane is the live registry visualization. The builder is a visual authoring tool for registry JSON. Instead of writing large JSON or Python objects by hand, you author sections, items, fragments, and groups through a structured UI. The assembly order panel shows exactly which tokens will appear in the final prompt and in what sequence. Section cards show each bucket of authored content, and item details shows the context, conditional fragments gated by template variables, and behavioral directive groups attached to each item. Registries can be exported as JSON, imported back, or sent directly to the studio for testing. The studio is the live testing environment. Load a registry, adjust runtime state, preview the assembled prompt, and generate against your local model, all in one view. You can fine-tune runtime state and verify that the registry produces the behavior you intended before deploying it. State controls let you select which persona is active, set slider values for sentiment dimensions, and choose a named route that overrides assembly order or generation parameters. The assembled prompt updates live as the state changes. The generate panel sends the prompt to your configured local model and streams the response back. In ensemble mode, each participant has memory, summarization, emotional state, working notes, and retrieval systems. The scenario is guided by domain, persona, tone, and behavioral constraints, but the output is still non-deterministic. It's meant to play out in a dynamic multi-agent scenario than to build a specific product, but it can be used for both. It's kind of like the difference between scripted dialogue and improv with some constraints. The registry defines the stage, the character, and the behavioral boundaries, but what gets said inside those boundaries is generated dynamically by the model. The memory system gives agents continuity without replaying the entire conversation every single turn. Retrieval memory embeds exchanges and injects relevant prior context as memory recall. Classifier rules generate tags and apply temporary guidance for the current turn. Emotional state tracks warmth, trust, tension, and playfulness. This accumulates and decays over time. Style blending lets behavior drift continuously without replacing the base persona. Working notes summarize what matters next and keep long interactions oriented. The Chat LLM Builder is a two-pane interface for building registries through conversation. The left pane is the chat, and the right pane is the live registry visualization. You describe what you want, and it streams the tool calls. It builds the registry incrementally. Describe the model registry you want in plain conversation, and an assistant builds the registry for you through that conversation. And what's interesting about that? This assistant is itself running on PromptLibretto registries the whole time. So you're using the framework to build the framework, which, honestly, is exactly the kind of thing it was designed for. This AI assistant is a PromptLibretto registry assistant whose job is building PromptLibretto registries. For Studio and Ensemble, the browser asks PromptLibretto to assemble the prompt, and then it sends it directly to the local LLM. Cores must be set to allow the browser origin. PromptLibretto is not an LLM proxy. Prompts, model responses, embeddings, and classifications stay local on your machine. The result is a framework for building adaptive conversational agents, persistent character systems, and structured prompt architectures that are non-deterministic but behaviorally coherent. The entire goal is to turn prompt engineering into a structured runtime system. Instead of manually concatenating prompt strings, it provides declarative registries, dynamic assembly, memory systems, emotional modeling, as well as multi-agent orchestration. The result is an adaptive framework for building adaptive conversational agents. This allows us to leverage structured prompt architectures to generate non-deterministic but behaviorally coherent AI interactions. Shit, that was hard. So yeah, this is the tool I was talking about. This is the front end for PromptLibretto, the prompt constructor. I'm gonna go kind of quick through this because I don't have a ton of time. But you can access this from PromptLibretto.readtheerror.com. In order to connect your local LLM models to the browser client side and the local no server calls, you can go ahead and click the how local calls are made. You can read this. You basically just have to allow an exception for your core setting to allow the communication between the browser and your LLM model. If you don't want to use the embed or classifier models, you can turn them off with this. You should be able to test and make all your connections here. The builder looks like this. Yes. Studio looks like this. I'll show you more of this in a second. One thing I thought was kind of cool, actually, that I did sort of recently. There's a guy I was watching on Twitch just randomly, and he was working on a Twitch bot that was like accessing a bunch of information via RAG methods. And it was taking him like 30 seconds to get some information about like one thing about his car or whatever. And I'm sure he had a lot more data than me. His RAG was like pilfering through or whatever. But I just kind of wondered if this chat model, the one that is on the prompt constructor, I kind of wondered if that would be able to make a model registry just on its own with this data and it like actually work. So let me go ahead and this is copy library 15-year build copy.
build for over 15 years now. It's got a serious heart with that CA18 DET swap, Tom cams, and GT2871R turbo setup. From the Apexi Power FC tuning to the Megan racing coilovers under the chassis, every detail has been chosen for reliability and performance.
What kind of boost controller and tension rods do we have installed?
We are running an Apexi AVCR, Advanced Vacuum Control Regulator, as our boost controller, paired with SPL tension rods for the front suspension. Is there anything specific about this build you'd like to discuss?